So yeah, this is the second installment of the tutorial series. Sorry, the guy in the we took over the room. So last time Eli went over player and camera controls with you guys, right? So I believe last time, like, you just bought a basic character moving around in the scene. Today we're going to be going over blocks. How much did Eli talk about what the game actually will be? Did he talk about it much? Did he mention blocks at all? All right, nice. Okay, yeah. So basically, it's hard to get a final idea because we're actually not completely finished with the tutorial series. We're kind of working on it as we go, but it's gonna, yeah. So the goal of it is to kind of be a Minecraft clone-ish. Obviously, way more simple. But you know, for a Minecraft clone, we obviously need blocks, which make up the world. So this is kind of like the main tentative structure of the tutorial series. So yeah, like I mentioned, player camera controls. We're going to be going over blocks today, and then tomorrow. Let me just close the door real quick. Yeah. So the goal with the next one is we're going to be going over player block interaction. So super basic stuff like, you know, in Minecraft, obviously they destroy blocks. You know, you want to be able to pick up the resource that the block drops, putting new blocks in the scene, stuff like that. So that's going to be hopefully tutorial series 3 and 4, and then series 5 is going to be more advanced block spawning. So today we're just going to be going over some super basic block spawning and kind of setting up the framework for that. But then tutorial series we're going to be going over hopefully some more advanced spawning techniques. Hopefully some that are actually used in Minecraft, or maybe at least when it first started. And then series the 6th one is just going to be kind of closing off, maybe cleaning up some stuff, adding some more visual feedback, some more polish, kind of making the game, finalizing the game. So yeah, just a note, this might change. Just because, like I mentioned before, we're kind of working on this as we go, so it might change as we go along. So yeah, today's agenda, we're going to be going over blocks, the idea of a block as a game object. We're going to be going over our block spawner, and we're going to be going over the manager design pattern, which is a super useful pattern, design pattern in Unity, or pretty much every game engine. So essentially, a manager we'll get into it more later, but the idea of a manager is essentially something that, actually I think I have a slide on it later, so I'll talk about it in a sec. But yeah, after we talk about that for a little bit, maybe 5 minutes, we're going to actually dive into the project. I don't know if Eli had slides before. Did he? Okay, yeah. I'm just going to have some slides to talk about some stuff, and then we'll start coding. Right, so a block, I'm sure you guys have seen Minecraft or probably played it. It's just a 3D cube that makes up the scene, and each cube is associated with a different resource. It's supposed to represent some kind of resource, and yeah, it's basically the building block of our scene. A block spawner is another object that we're going to be talking about today. It's basically the class or the object that is going to be in charge of spawning initially all of the blocks in the scene. So we're going to be going over some basic ways to do that. Right, so the manager design pattern. So essentially, maybe some of you have seen this before, but essentially a manager in a game engine is usually some kind of object there's only one of them, and they manage some sort of some sort of property or system in the game. So for example, what example do I have here? Network manager. So example, in terms of communicating with the server, for example, there might be one network manager which is in charge of all of that. A sound manager which is in charge of maybe spawning all the sounds in the game. Today we're going to be going over a block manager, which is going to be going over managing pretty much all of the blocks in our scene. So if we think about a bunch of blocks in the scene, that naturally translates into a list of blocks. So naturally, we kind of want something to own that list of blocks, right? And that's going to be the block manager. And obviously, we're going to get into it as we go along here. Yeah, one thing to note here is that this is technically not necessary for this project. Like a block manager is kind of maybe overkill. There is something called like over-engineering a project, but we thought that we would definitely bring it up today just because it is an important topic. Yeah, so Unity time, I guess. Let me just make sure that I'm recording. I think I am. Okay. This is the first time I've done like a live coding workshop thing, so hopefully this doesn't crash and burn. Did the one with Eli go well? What's up? Sure. I think in terms of like the player block interaction, like the way the player is going to kind of manipulate the scene is going to be by using the block manager, but the actual logic in terms of how the player interacts with the block is going to be somewhere else. So for example, like the block manager, if we want to delete a block, for example, since the block manager is going to own all of the blocks, it would be natural to like tell the block manager what we want to do with the block, and then the block manager manages how to do it. But like, for example, like another system will be responsible for sending that request to the block manager. That's a good question. Okay. What's up? I think you guys can probably just use the same scene. It would probably be easier. Yeah, exactly. I guess for the recording, I should probably repeat questions. But yeah, basically, we're just going to be working off of the same scene from last time. So let me open that up. Hopefully it works. That would kind of suck if it didn't work at all. That's interesting. Okay, I'm going to make a new scene just because apparently I'm missing prefabs on this, but if your scene is working, then you should be safe to just use your own scene. So the first thing that we need to do is make a block script. So the recording. Hello. We're having some issues with the wire apparently. Wow, this is pretty jank. I think the wire is like unplugged. If it unplugs at any time, let me know, because I can't really see the screen. So yeah, so the first idea is that we need to have a block script, right? Because if you think about it, like we can have this game object, and it's going to be the way we're going to know if it's a block is we can either tag it as it's a block, but eventually we're going to have maybe some resources and some logic related to blocks, so we're going to encapsulate that into a block script. So if you go, we have all of our assets. We go back to the scripts folder. We can just simply right-click, create new C# script. Now we're just going to call that block. Open that up. So right now it's going to be super simple. Like we're not even going to add anything in this. It's just going to be like we're just making the skeleton essentially for it. Hello, Visual Studio. Okay. So did Eli cover prefabs last tutorial? Temporarily? Okay. It's kind of hard for me because there was some issues with the recording, so I didn't actually get to hear his talk. But essentially, like, one way we could do this is, let me just go ahead and wait for Visual Studio to eventually open up. Hello. Okay, so let me see what kind of prefabs he has there. Okay. So let's just go ahead and make like a super basic like wood block. Okay, so if we go ahead and go in the scene and create a new 3D object, I'll get to the script in a second. But if we go to the 3D object, make a cube in our scene. If you click F, don't know if you how familiar. Hopefully, you guys are kind of familiar with the UI for Unity at this point. But if you click F, it'll zoom in on the object that you selected. I like to just reset the transform to 0, 0, 0. That's just something that I like to do. But so now we have a cube, and basically in terms of like the block mesh, we're done, right? Like this is it. A block is just a cube. So I'm gonna go ahead and call this wood. And then we can basically, so just to confirm, he didn't cover prefabs last tutorial? Are you guys do you want me to kind of go over what a prefab is, or are you guys comfortable with that concept? Maybe I'll briefly mention it. So basically, like, we have our game objects, which are like in the scene, but if we have a game object that's going to be, we want to like basically save that game object to be able to instantiate it at later points. The way Unity basically does that is by creating a prefab for that object. So think of a prefab as basically like a saved version of that game object, and then we can just load it in at any point. So the way we're going to approach this is that for every single type of block, we're going to create a prefab for that block. So here we have, oh, you guys can't see the whole thing. That kind of sucks. But yeah, so for this block, we're going to call it wood. I did have a wood texture, but just a kind of on the fly thing. Let's find the wood texture. This is some real, let's go ahead and say Minecraft wood texture. And let's go ahead. This is how it's done usually. Or if you have an artist, you can just tell them to make the texture for you. Feel free to use any texture you want. I'm just gonna, for educational purposes, I'm just gonna do this. So I'm gonna make a new folder here. If you can't find a texture, don't worry about it. But I'm just gonna do that because it looks nice. So I'm gonna make a new folder here called textures, and then simply just drag the texture into. I've lost where I saved the texture. If you just drag the texture into it, it should work fine. There we go. So we now added the texture into the folder. So the thing is, you can't just add a texture directly onto an object. The visual representation of an object, like kind of if you went to the intro to game tech dev talk, is represented by the material of the object. So any kind of texture is associated with the material. So what we actually want to do is create a new material and then add that wood texture that we just downloaded to the wood material. So we're going to go ahead and create another folder. It's good to organize your project like this. Call it materials. Oh, we already have a materials folder, excuse me. In that case, so open up the materials folder, right click, create material, call it wood. And then in this albedo field in this material, that's basically what the color of the, some engines might mention this as diffuse or even just color, but you can think of albedo as just the color of the material that you can see. So in Unity, if you click this circle thing here next to the property, it'll open up this dialog, which is basically all the textures that you've loaded into the scene, and we should see the wood texture. And again, if you didn't download a wood texture, feel free to use just whatever if you want. Also, you don't really even need the texture, but just to make it look nice. So now you can see that the wood material actually looks like wood now. So then we can just simply drag and drop that onto the game object. And now we have our wood block. This is basically as super simple as it gets in terms of assets, but right. One thing that I'm also going to do, just kind of, you'll notice that if I kind of look at this object at an angle, we're going to get some specular reflectance here. If you don't know what specular reflectance is, it's basically like the light. If you see a car, if you look at a highlight in a car when it's like the sun is hitting it at a certain angle, and that kind of shine that it hits, that's basically specular reflectance. And it looks really weird that this wood is behaving this way. So just as something just for funsies, we're going to reduce the smoothness on the texture. So you'll see on the wood material, there's a smoothness factor, and this basically controls the specular reflectance. So if we just put it all the way to 0, we should basically remove that reflectance, and then it looks more of like what an actual wood texture might look like here. Okay, so at this point, the only thing we're missing now is the block script that we kind of created before, which is completely empty at this point again. So I can just basically add it by either dragging and dropping the script, or I can either go add component and then look up the script and do it that way as well. Have I lost anyone? Is there anything that you guys want me to go over real quick? No? Okay, perfect. So we've made the wood block. So like I mentioned before, we actually want to save this now, and that's basically how I mentioned that before, is we make a prefab for that wood texture, wood block. So that's pretty simple. We just go to prefabs and drag the wood game object into our prefabs folder. So you'll notice that once you make it a prefab in the editor here, it's now blue. So any blue game objects in this hierarchy view here, if it's blue, that basically represents that that's an instance of a prefab object. So that's kind of useful to work with. And you'll also notice that the reason I set it to 0, 0, 0, the position initially, is because I've ran into issues before where if the prefab has a position and orientation, it kind of messes things up down the road. Potentially, you might get some like really weird bugs. So I usually like to set, when I create a prefab, I like to change the position to 0, 0, 0. Okay, so now we have this nice wood block. Just before we go forward with the block spawner, is there anything I should go over? You guys are good? Perfect. So let me just look at my notes here. So, sweet. So what we're going to do next is get started on the block manager. So like I mentioned before, the block manager is going to basically encapsulate everything to do with managing blocks. So creating a new block, it's going to own all of the blocks. If you want to delete a block, manipulate a block, it's basically all going to be, all that logic is going to be maintained in the block manager. So if we go back to scripts, go create C# script, call it block manager. Just in terms of like how fast I should be going, is anyone like following along, or are you guys planning to kind of do this afterwards? Like show of hands, who's like actually following along with me? Okay, so most of you. Okay, so I'll try to go slower then. Sweet. So now we have a script, but this doesn't really tell us. Like basically, a script is just a piece of code. It's not actually a thing within our game. So we actually need a game object which is going to represent the block manager in the scene. So we're going to go ahead and create an empty game object. And by making it empty, we basically say that we don't care about any components. This is just like an empty game object in our scene. I'm going to call that block manager. And then we can go ahead and add our new empty block manager script onto the new empty block manager object. So you'll notice that we can move the block. It's empty, but we can still move it around because it has a transform component. But it's an empty game object because we only really care about the script behavior. We don't actually care about anything else. So let's go ahead and open up the block manager script. So I mentioned before that the block manager is going to have a list of the blocks that are in the scene. So let's go ahead and do that. I'm just going to actually let's just keep that there for now. So in C# we can just have a list of blocks, and then we'll call that. Do I have it here? Not like it really matters too much. So let's just call it block list. So this is basically our list of blocks, and this is pretty useless to us right now because we don't have any method of actually generating the blocks, right? So, if we go back to our scene and we start it, obviously we're expecting nothing to happen. But that's one thing that I kind of may have briefly mentioned before, but we're going to actually get it into depth now, is that a manager, there's only one instance of a manager at all times. You know, by the very nature of a manager, especially the block manager, for example, the block manager is going to own and maintain all of the blocks. So it doesn't really make sense to have multiple block managers because we want that block manager to be the central source of contact when we're manipulating all the blocks. So kind of just a show of hands, like has anyone worked with like the singleton pattern before? Has anyone heard of that pattern? No? Okay, sweet. So basically the singleton pattern, it's a design pattern. And a design pattern, if you guys haven't heard of that, is basically just like, it's just different, I think of it as different design strategies, like different coding design strategies and methods that have kind of been reused a lot and are now patterns that are commonly used anywhere in code. So a singleton pattern is basically a singleton class is basically a class that there's only one instance of that class, and you're only allowed to instantiate one instance of the class. So if you think of like this block class, right, that we've made here, you can create as many blocks as you want, and that makes sense because we're going to have multiple blocks in the scene. But it's not like super intuitive like how we would like limit a class to only have one instance of it, because you know anyone can create it, right? But there's actually a nice little singleton pattern where you can only have one instance of the class. So the way we're going to do this, yeah. Oh, shit. Just like zoom in. That's probably a very good call. Yeah, sorry about that. So the way we're going to do this is in the block manager class, we are going to have a private instance, private static instance of the block manager. We're just going to initialize it to null. So let's look at this for a second here. So, you know, private means that only methods within the class can access it. Static means that this can be basically, there's only one instance, there's only one copy of that variable, right? Instead of it being, like if you have like a block, for example, I don't know, if you have like an int variable, whenever we instantiate this class or any class, every single instance of that class will have a new copy of this variable, right? But when you make the variable static, it's basically saying that there's only one instance of that variable, and all of the instances of the class share that one variable. And this might seem pretty weird that we have a variable, we have an instance of the class within the class itself. But this is actually how singleton works, and this is how we're going to actually maintain that there's only one object, one instance of that class anywhere in the scene. So this is like a super useful pattern, and it's very good to learn about even without game development. Outside of game development, it's used a lot. So cool. So now we have this instance class, and what we're going to do is we're going to make a public void awake. So this is a method that Unity calls. We don't actually call this method. It's similar to start and update, where Unity is calling this method. We don't touch it at all. But basically, this method is called once when the scene is first loaded in. Like when you first start the game, the scene, basically every single entity that's enabled in our scene will have its awake method called. And basically what we're going to do here is we're going to say, if our block manager instance is equal to null, we basically want to set that instance equal to ourselves. Else, we're going to destroy this. Now, this is probably not like super intuitive what this is doing immediately if this is the first time you're exposed to this pattern. Like it definitely took a bit of time for myself to wrap my head around it, but essentially what we're saying is, if you can think about it as like, we have this static variable, and the first time that manager is awakened by this awake method, we basically set that reference to point to ourselves. Else, if this isn't null, that means it's already set. That must mean that there's more than one block manager class, and then I want to destroy myself, right? So this might be easier to understand if we just go in the scene and just play around with it. So right now we have one block manager. Did everyone get this, by the way? Did anyone want me to show this? Everyone's got this? Cool. So if we go back in the scene, start this up, as expected, this block manager is still intact. It's our only block manager. This is kind of what we're expecting. But let's see what happens when we make a new block manager. You don't really need to do this, by the way, but just for demonstrative purposes, let's make another block manager. So obviously this kind of violates the rule that we're having where we only have one block manager in the scene. So when we go ahead and start this, we can see that only one of the block manager objects here will actually have the block manager script associated with it. So, I mean, it kind of sucks that we can't determine which one is going to be the one that has it because, we can't determine which order that these block managers will be instantiated. But, like, for example, this one definitely started first. So when the awake method was called on this script, we saw that the instance was set to null. We then set the instance equal to this, and that's it. So now instance points to this specific game object's block manager object. Next, this block manager will get instantiated. Again, the awake method is called again. So we see if instance is equal to null, we set instance to this, but we know that the instance was previously set by the other block manager. So at this point, we just destroy it. So any other block managers that might be in our scene, since the instance here is already set, basically all the other, we just delete all of them. So to make sure there's only one of them in our scene. So that's kind of the instance manager, the singleton pattern in Unity, kind of in a nutshell. Did anyone want me to kind of go over that again, or any questions regarding the singleton pattern? Sweet. Okay. Awesome. So for spawning all the blocks, we could have like a method here called like spawn blocks, and that might contain all of the logic of spawning the blocks, but that's kind of not the best design because we might have different ways of spawning blocks and we might want to change them, maybe have like parts of the scene be rendered this way and parts of the scene be rendered this way. So we've chosen to kind of separate the actual spawning of the block from the block manager, but the block manager will still contain, so basically the logic of the block spawning is going to be in a block spawner class, and the block manager will own an instance of that class. So I'll get into that in a second here. So, but let's go back for instance, back to the scripts, and let's create a new script called I block spawner. So let's open that up. So has anyone here kind of read about like kind of abstract classes, and the name is escaping me for whatever reason. Excuse me. I don't know why this word, I've said this word so many times and I can't remember. Oh, interface. Has anyone worked with interfaces before in any programming language? Yeah, you guys. Okay, so basically, if you aren't familiar with the idea of like an interface or an abstract class, essentially an interface, the two are the same. I'm just going to call it interface for now. But an interface is basically a class that can't be instantiated, but other classes can inherit from it and basically implement that interface. So the details will become more apparent again as I kind of work through this. So if there's something that you don't understand at this point, either ask questions, feel free to ask questions, but maybe in like 2 minutes your question might be answered by just how we're using this. So in C#, if you want to make an interface, we basically, instead of this public class syntax here before the name of the class, we're going to place that with interface. Pretty easy. And since it's an interface, We actually don't want it to inherit from monobehavior here. Monobehavior is a class that Unity implements that basically any script that is attached to a game object needs to inherit from monobehavior, but we don't need to worry about that right now, so we just remove that. So we just have this super simple interface here. And basically the interface, whatever methods are contained in the interface, any class that inherits from that interface or implements that interface needs to have definitions of all the methods in the interface. So the only method that we're going to do in this block spawner interface is we're going to have a method that's called spawn blocks. So this is the only method contained in the block spawner interface. So essentially if we go back to block manager, we can actually add a block spawner into our block manager now. So if we have a spawner interface and we say block spawner, so now block manager owns an instance of a block spawner. One thing to note here is that an interface, like I mentioned before, doesn't actually implement any logic. An interface is simply like, think of an interface as like basically like a blueprint, where like if you have an instance of an interface, you know for a fact that every method or everything outlined in that blueprint is there, but the actual implementation of the blueprint is implemented by the classes that implement the interface. So another good analogy, I guess, or maybe not so great of analogy, like let's say you have like a blueprint for like a factory, like you're some kind of business, you're creating factories, and you make a blueprint for a factory that says, okay, the factories must have garage, like an input garage, and they must have a garage that like shipments go out of, and they must have a door where workers can go into. So you know by looking at that blueprint that you're guaranteed that any factory that implements this blueprint has, you know, an input garage, an output garage, and a door that employees can walk into. So an interface in programming is kind of the same thing. If you have a block spawner instance, you're guaranteed that the instance implements spawn blocks. You don't know what spawn blocks is, you don't know what it's doing, but you're guaranteed if you call spawn blocks that it implements some kind of functionality. So does anyone kind of want me to cover interface, or is everyone good on that front? Okay. So now, you know, we have this interface for a block spawner. We actually want to implement a block spawner now, right? So let's go ahead and create a new script. Okay, so I'm going to call this uniform 2D spawner. So go ahead and open that in Visual Studio. I don't know why this laptop is so slow. We paid way too much money for this laptop to be this slow. So sweet. So now we have this spawner. So this is going to be the actual class that's going to implement the spawning logic. But one detail that we shouldn't forget here is that we want the block manager to implement the block spawner interface. It's probably complaining now, right? So by inheriting from monobehavior, we basically allow that script to be added onto a game object, and then by implementing this block spawner interface, we basically make sure that anyone who wants a block spawner can contain an instance of uniform 2D spawner. And it's going to complain now. I don't know if you guys can read that, but it's basically complaining here that we don't implement the spawn blocks method, right? Because as mentioned before, this interface has a spawn blocks method. So any class that inherits or implements this interface must implement all of the functions outlined in that interface. So let's go ahead and do that now. So we are going to have a public spawn blocks method. so sorry, it's going to return a list of all of the blocks that we just spawned. One thing, why is this still complaining? Oh, it's because I haven't implemented it. So basically there's a bunch of different ways that you can be able to spawn blocks, but just for simplicity, the way I'm going to do this right now is I'm going to just make a grid of blocks, like a 2D grid of blocks. And just to make it more interesting, we're going to randomly have holes in the block, in the grid. So that kind of requires some parameters into the spawner, just so we make sure that, we can have different variants of the grid. So I actually think I have a picture of that here. Yeah, so it's going to look something like this, where it's just a huge plane of grids, a 2D plane of grids, and it's going to have randomly a bunch of blocks in it, holes in it, excuse me. So I'm just going to have some parameters just because, just to have some functionality. We might want to make a big grid, we might make a small grid, just to be able to control the actual spawner. So let's make a width field. What else would we have? We need a height, and I'm going to make a hole probability variable. So hole probability is just going to control the probability at which we're going to have holes. So, obviously if we have a higher hole probability, the more holes that are going to be in our grid. And we're also going to have a block prefab field. So this is going to basically be the block that we're going to be spawning. So right now we're only going to be spawning one block just for simplicity, and then maybe later we're going to be able to maybe spawn multiple different types of blocks, maybe randomly select the blocks. Basically this is the functionality of a block spawner is basically endless, but we're just going to start simple for now. So basically this is going to start off by creating our list of blocks. So let's call this spawn blocks, and it's just going to be new list of blocks, block. And we know that eventually we're going to return this. I just want to put this here just so this stops complaining at me for not returning a value. So now we need to actually spawn blocks, right? Does anyone want to kind of gander how we might do this? So I've been super vague in how this is going to look like, but we're going to have a 2D grid of blocks, and we're going to randomly have holes in them. So just kind of approaching this from the outside. Does anyone have any ideas how we could do this potentially? We have an int, we have a width and height field, and hole probability given to us. Yeah. Exactly. That's exactly what we're doing. So, super simple. We don't need to get anything complicated. This is simply just 2 for loops. It's going to be this entire algorithm. So we're going to have one loop looping through our rows. So simple for loop here. We're going to have another for loop looping through our columns. I guess height doesn't make sense here because it's 2D, but that's fine. So now we're basically going through and making sure that we're going through all the width, basically going, we're basically going to be executing this code, so spawn block. This spawn block code here is going to be executed width times height times, because that's how many blocks we're going to spawn. Okay. So just to start off, one thing that we could do is just spawn the block and then check with the hole probability, and then destroy the block, but that's kind of wasteful. So we're gonna actually check if we want a hole first before we spawn anything. So in Unity, this can be done by just calling random.randomRange, and it basically accepts a min and max value. We're just going to do 0 to 1. So this is going to give us, it's actually deprecated just because, I don't know, but it works, so I'm just going to use it for now. I don't actually know why it's deprecated, but Right, so this is basically going to return us a float number from 0 to 1. And that's pretty useful because, obviously this whole probability now needs to be within this range. So needs to be within 0 and 1. So the way we can basically control this is if we want a 20% chance of having a whole probability will just be 0.2. And rand will obviously return a number from 0 to 1. So the way that we're going to check if we want a whole is we're going to say if rand is less than or equal to the whole probability, then we just continue. So continue will just basically skip that iteration of the for loop. So does anyone have like an intuitive grasp of how this is working, or maybe dive into this a bit more? So yeah, I mean, it's pretty simple. Like if we have this random value has a uniformly chance of being any value between 0 and 1. So if we have whole probability set to like 0.2, then there's a 20% chance. There's a 20% chance, since it's uniform, that rand will be also less than 0.2. So if we just check that rand is less than the whole probability, that's basically saying that this will be executed 20% of the time if whole probability is 0.2. Yep. This one? So random, this random range method is basically a function provided to us by Unity. So this is not something that we implemented, it's just part of the library. So if we go Unity random range, whenever there's a method that kind of doesn't make sense, it's a great idea to look it up on Unity. I guess this is a better, let's just, so it doesn't complain at me, let's just change this to range. But yeah, so basically this describes how you would use it, what the function does. So this is all implemented and given to us by Unity. Okay. So yeah, so now we've handled the case where we don't want to spawn a block, but now we should handle the case that we do spawn a block. So, this might be a bit weird if the blocks are different sizes, but if you imagine just going through all the different points on the grid, where the actual position that we're going to be spawning the blocks, we need to account for the actual size of the blocks, right? Because if we simply go through this without taking into account the size of the block, then we're not actually, the blocks aren't going to be side to side, right next to each other, right? If we actually go back to Unity, we'll know that this block is just size 1, 1, 1. So now we know that half of the block is 0.5, right? So basically, let me just write this down, and maybe we can go over it together. So the x position, we have the x position of the block. So basically what we're doing is we're saying that the actual position, the x position of the block that we're spawning is going to be r times the x size of the block. So, we know that this for loop is starting from 0 and going to width. So it's going to be, 0, 1, 2, 3, 4, whatever, all the way up to width. But, I guess in this case, this technically isn't necessary because the local scale is 1, but it's good to have it here in case you change the size. But for example, let's take the case where the block prefab actually has a scale size, local scale size of 2. If we actually just use the r value as the x position, we're going to have 0, 1, 2, 3, all the way to width. But since the actual block is size 2, the blocks are going to be intersecting each other. They're not going to be flush right against each other. So by basically saying r times the local scale, we're going to make sure that we're skipping by the size of the block. So that way the blocks will be right next to each other. Okay. Is that any confusion there about that? So we're just gonna do the same thing with the Z value. But now using the C here. I just like to use, whenever I have a 2D for loop, I like to use R and C just because it makes more intuitive sense, row and column. You don't need to do that, but. And now we're just going to use, technically you could use the X scale again, but just for formality, let's use the Z scale, just in case we have some weird scene with a rectangular prisms. Sweet, so now we have the X value, so now all we need to do is just actually instantiate the block. We have the position, we just need to create that block at that position. So the way that we do that, as we know, we go game object dot instantiate, and there's a bunch of different ways that we can call this because it's overloaded a bunch of times, but the way we're going to do it is we're going to pass in the block prefab. We're going to pass in a new vector that's basically going to be our position, and quaternion dot identity. I'm going to say as block. So let's go through this together here. So, yeah, what's up? Yeah, so we could use Y, but in this case, like in Unity, Y is like up. So if we want it to be all on the same like flat plane, we just set Y to 0. All right, so instantiate is basically we're going to instantiate a new game object that we're going to set to equal. We're going to put into our block variable here, and basically these parameters that we're passing in, the block prefab, which is basically the prefab that we previously passed into the spawner. So in this simple case, we're probably just going to have. We're going to give the block spanner spawner, I don't know why I keep pronouncing it that way. The block spawner is going to be given the wood prefab that we made previously, and it's going to be just instantiating a bunch of copies of that prefab. We pass in the position, which is just a vector of the X and Z variables that we just calculated. And quaternion identity, this is just the rotation. Don't worry about what a quaternion is, but just, this is basically saying that the orientation is 0. There's no rotation. Rotation is 0, 0, 0. And we need to cast it as a block, just because if not, then C# is going to complain at us. Because this instantiate method actually returns a game object. But if we say as block, it gets casted as a block. So just minor implementation details. And then finally, we've instantiated this block, but we want to make sure that we manage the block, right? So we want to add that block into our spawn blocks list, which we made here, and then we simply return that block, the spawn blocks list. Is that clear to everyone? Is there any questions about the block spawner? So yeah, basically, as a summary, this is just going to create a 2D grid of a bunch of blocks, and we're going to randomly have holes in the blocks. So pretty simple block spawner, but cool to start out with. So, if we go back to the block manager, the 2D spawner is basically done now. That implementation is complete. If we go back to the block manager, we have an instance of this block spawner. But now we actually need to fill that with some block spawner, right? So there's probably really nice and elegant ways of doing this. You could, for example, have like a text file where it reads the text file, and then you can have like different block spawners that are used, or you can maybe like, depending on which scene, like have the block manager spawn different spawners. But just to keep it extremely simple, all we're gonna do is basically in this awake method, we're just gonna have block spawner be a new instance of the uniform 2D spawner. So this kind of defeats the purpose of having this interface, because we could have just had this be a uniform 2D spawner. But again, kind of the goal with this tutorial is to introduce some new topics that are going to be useful down the road. So a lot of the stuff I'm going to be introducing is kind of overkill for this small example, but it's just useful to know. So for example, just summarizing the benefit of making this interface is that we could have like 100 different spawners. As long as they implement this block spawner interface, we can easily swap them in our block manager. So we have block spawner is going to be our new uniform 2D spawner. Let's just go ahead and call spawn blocks. And I'm just going to let our block list be equal to the spawn block. So just to summarize here, we've created a new instance of our block manager, uniform 2D spawner, and then we're just going to call the spawn blocks method, which we implemented here, which is going to basically create a bunch of blocks and then return that spawn list. And then we're going to just set that equal to our block list. So our block manager now has a block spawner, and it now has a list of the spawn blocks from that block spawner. So let's go back into our scene and see what happens. I'm just going to delete this duplicate here. Okay, let me delete this. Oh, one thing that I totally forgot to do was set the width, height, hole probability, and block prefab parameters, fields in the 2D spawner. So let's go ahead and do that actually, because that's probably an important thing. So we just remember how I do it here. Oh, excuse me. Yeah, this actually shouldn't be how we're spawning, creating an instance of the spawner. Just to make it easier for us, sorry, completely forget I did this. Since this 2D spawner actually inherits from mono behavior, we can add the spawner directly into our block manager game object. So if we go back here, we can actually add that into our game object. Again, this probably isn't the most elegant solution, just because, what happens if we have all of these spawners attached? It might not be the best way to do this, but just by doing this, it makes it a lot easier to get it. So if we go back into this block manager, we're actually going to say block spawner is going to be equal to get component and block spawner. So basically, this is just going to get the component that's attached to it. Obviously, if we don't have a component attached to the game object that inherits from the iBlock spawner interface, then this is just going to return null. But since we do, this is going to be set to our instance of the uniform 2D spawner. So this allows us to basically control the parameters directly in here. So you'll notice that since we have all those variables are public, we can just change these here. So let's make this 10, 10. Let's make the whole probability 0.2, because remember that needs to be between 0 and 1. And for the block prefab, we can just drag in the wood prefab that we made. We can just drag it right into the field here, and that'll be associated with it. So let me just review this to make sure that this works. Oh, excuse me. Yeah, so we forgot to call, like I deleted before, we want to obviously call spawn blocks. And we want to make block list equal to that. So let's just see what happens. Hopefully something should happen. Cool. So there is our grid. So I mean, I'm not going to count, but hopefully these holes are happening with 20%. I think it's a bit less than that, just from looking at it maybe, but it's random chance, so we might have more or less than 20%, but in general, that is our new spawned block list. So hopefully if you guys clicked play, it did the same thing for you. Just for fun, let's make this some ridiculous number. See what happens. It's a pretty cool, like, scalable solution because, we can just change the actual size of the map programmatically instead of actually having to hand write all of the blocks. And apparently Unity can't make that many blocks, so I've frozen the application. That's fantastic. I probably should have known that would have happened. Let me restart. Did it work for you guys? Is anyone successful with making it? Let me just kill Unity real quick. Oh boy. Okay. Did anyone have any questions about what we've covered so far? Yeah. Yeah, I mean, the block script is actually just completely empty for now. In the future, though, like, for example, this might contain, like, in reality, this is kind of another example of over-engineering this. Like, the actual idea of having this probably isn't, like, completely necessary at this very, very small project. But things like what resource this block is associated with, or maybe, like, you know, depending in Minecraft, like, different blocks will have, you know, you might need to hit it different amount of times in order to actually collect that block. So all that information will be eventually included into the block class. So it's just a super skeleton for now. Yeah. Yeah. Oh, okay. That happens. Is anything showing up on the screen? Like, do any blocks get spawned, or? Okay. Sorry, let me just open this up. Yeah, that's fine. Can you show me what you're from? So for this, just a syntax issue for this one. It's because you have to, this needs to be semicolon. And this is 2. Yeah, no worries. You want to return after the it might not spawn anything if you haven't. You have to change the parameter. You have to add it to the. You have to change these values. If you want to, you know, change the width and height. All right. Let's go back in and maybe. Oh, okay. Tutorial 1 is apparently working for some reason. I kind of just wanted to have like a final run where we're making like a big scene. One thing that I haven't mentioned that's kind of important in the singleton pattern that I kind of just realized is that if we go back to the block manager, sorry, could you guys? I'll just wait for the door to open there. So one important detail about the singleton pattern is that usually the singleton pattern also allows you to have global access to the single instance. So like for example, like one cool thing about the block manager is, or a singleton pattern is, it can basically be accessed anywhere in the code. It's kind of like a global variable, which has its obvious downsides because it's a global variable. It can be accessed anywhere and anyone can change it, which can be super dangerous. But I actually haven't implemented that functionality here. So in order to do that, we actually need to have we can just simply have a getter for the instance, a static getter. This actually isn't really super important for the tutorial, but just to kind of close off the idea of a singleton pattern for you guys. So if we have like a public static method called getInstance, we just make this return instance. Essentially, returns a block manager. So essentially, like anywhere in the code, since this is a static method, anywhere in the code, we can get the instance of the block manager, which is pretty cool. Just because, you know, anywhere, it's super dangerous as well, because if you think about it, if we have a method here called like delete block, that means that anyone anywhere in the code can delete a block, but it makes it really easy to work with, especially with these block managers, because there's like global points of entry. So if you've noticed that, like, you know, for example, like the input manager that's implemented by Unity, all of these methods, or the vast majority of them, are public static methods. So it's really cool. The idea of a block manager or a manager is really cool as like this all-arounding like global thing that can be accessed to any points in the code. So to kind of illustrate that, just to make sure that you guys understand, we have like a get instance that's public static. So for example, if we have just, I don't know, for whatever reason, in our player manager, we can actually call this method. You don't need to write this, by the way, I'm just illustrating the point here. But we can call block manager.getInstance, and then we can refer to that specific instance of the block manager. So that, I mean, obviously there's no real use cases for that yet, but you'll realize in the future how pretty powerful that can be. Hopefully this has worked at this point. So just for closure here, let's go ahead and make sure the block wood prefab is attached. So if we go and insert that, we get a cool little 100 by 100 grid of blocks. That's pretty cool. I think in your scene, you should be able to walk on these. I don't know if you guys implemented physics last tutorial. I don't think you guys did, but I mean, technically this is our level now. I think that's honestly, I've been going pretty fast, I think, so that's kind of the end of the tutorial. Just because I kind of wanted to just go over the idea of a block, the block manager and spawning them. Yeah, I went through that maybe a bit fast, so if you guys have any questions about anything we covered, I can feel free. I mean, it's only 7:04.